guys, welcome to week Thursday, of Algebra 1, Semester 1, or Semester 2. How are you guys doing? So make sure you guys are watching this video on YouTube so you know what you're doing for this lesson today. So go ahead and pause the video for your warm-up today. Okay, so we're going to go ahead and create our lesson for Algebra 1 for Thursday. And so I'm going to go ahead and click on the assignment tab. Make sure you guys are doing the assignments on a regular basis. Remember, if you view the assignment, your attendance is taken. However, if you go ahead and upload your assignment, then you have the grade for that. So just keep that in mind. So week 3, Thursday, Algebra 1, Semester 2. And today's topic is going to be a review of exponential growth and decay with transformation of square root. So this is your instruction. Make sure you guys go on to week 3, Thursday. It needs to be equivalent of 55 minutes of instructions. If you need a hard copy, I do have them outside of my door, so you're welcome to do that. 10 points every day if you upload your assignment. And as always, it's due by 3 p.m. the following day. All right, so the assignment that you'll be using today is going to be looking like this. So let's go back over here to Algebra 1 and make sure that you guys have your worksheet. As you will have 2 today. And those are the 2 worksheets that you'll be using. This is your first one, and this is your second one. Okay, so with that said, let's continue on today's stuff then. All right. So first I'm going to do is I'm going to start off with the breakdown we're going to talk about today. So go ahead and take a look at what we're going to be going over. I'm going to start off with this page right here. All right. So with this assignment, what you're going to be asked to do is that you need to go ahead and show me what does a transformation of the square root looks like. Now, a square root is just going to be shaped like this, okay? Kind of like that squiggly little thing. So looking at number 1, with number 1, this means you're going to go up 1. The negative 2 means you're going to go 2 to the right. So I'm going to go up 1, 2 to the right, and this is my answer. So under the description, I'm going to put up 1, 2 to the right. For number 2, here we go. For number 2, this is just going to start in the center. So I'm going to put origin. 0, 0. There you go. For number 3, this is going to be 4 down. Okay. This 2 means that it's going to be a skinnier curve. So I'm going to put 4 down and then SK for skinny. 1, 2, 3, 4. And it's going to be like that. There we go. Okay, so for number 4, this means you go 3 down, 4 to the left. 3 down, 4 to the 1, 2, 3, 4. And here we go. Number 5, 3 up, and then 4 to the left. So 3 up, 1, 2, 3, 4 left, 1, 2, 3, 4. And that's what you should have. Now for number 6, you're going to have 2 down, 1 to the left, and there's a negative, so this negative means that it's reflective about the x-axis, which just means it's upside down. Okay, so let's try that. So 1 left, 2 down, and then reflected over the x-axis. So 1 left, 2 down, 1, 2, right here. So instead of going up, it's going to go down like this, like that. Okay, so now that I've done 1 to 6 for you guys, I want you to give 7, 8, 9, 10, 11, 12 a try and see what that looks like. So pause the video and answer the following questions. Okay, next what I'm gonna have you guys do is we are gonna jump right into Desmos. And Desmos looks like this, okay? It's gonna be on a match Marnus growth and decay. So I'm gonna help you guys set it up. Okay, so your session code is going to be 757R33. That is going to be your session code. And once you go ahead and type this into student.desmos.com, type in the session code, and you should be able to start these questions. And if you go ahead and type that in, you will be able to see how to go about answering these questions. And there are 16 questions, so make sure you do give me the answer for this. Okay, and of course you have like this part right here where it tells you to type in the answers, so make sure you do that. Okay. Okay, so the next thing that we're going to do in class today is going to be the following. Okay, so we're going to do a little foldable. Okay, so if you're at home, you can go ahead and just take a piece of paper. And with your piece of paper, you can go ahead and just fold it in half. So fold the paper in half. Then from there, you're going to go ahead and cut the paper 1, 2, 3, 4, 5, 6 with 6 different flaps. Actually, just kidding. 8 different flats. Let's try that one more time. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and once you have these flaps, we're going to go over the answers one for one. So flap number 1, it says y equals 50, 1.7 to the x power. So which one could be a graph to this equation? Well, first thing you should realize that if this number inside is bigger than 1, then you know it's an exponential growth. If it's a growth, what that means is going from a small number to a really big number very, very quickly. So it's going to go from a very small number to a really big number very quickly. So which one does this match? It will probably be A. Okay. Now with B, this is not an exponential growth. This is a linear. It's a linear graph. With C, that's an exponential decay. The first one, of course, is an exponential growth. And then, of course, the next one here is it's actually a growth, but it's a negative exponential growth. This one is just a positive, and this one is a positive exponential decay. Okay, let's take a look at the next one. Jeff buys a car for $28,000. The vehicle depreciates 16% each year. Which of the following is a common ratio for the sequence representing the car's value each year? Well, if it's going to be depreciating by 16% each year, that just means 100 minus 16%, which is 84%, which is 0.48. And that's the answer. So then the next question is, what will be the value of the car in 10 years? So this is the one where we're going to put it into the equation. Y is equal to, now inside the parenthesis is going to be the depreciation value, which is 0.84. On the outside is going to be the actual value of the car, which it started off with, which is 28,000. And on top here, it's going to be 10 years. Okay, so you're going to use a little calculator to do 0.84 caret 10 and go ahead and enter that on your calculator. That's going to give you a number of 0.1749. Now next what you're going to do is going to take this number and multiply it by 28,000. Which is going to be 489723. This is how much money, this is going to be the new value of your car after 10 years, which is $4,897, which makes sense because if you've driven the car in 10 years, it's probably over 100,000 miles and it's probably going to be old and beat up. So your new value for this car is $4,897. Okay, so let's go ahead and take a look at the next part. It says Jim invests $10,000 at 4% interest rate for 20 years. What is his profit going to be? Now, the equation for this is y is equal to a, 1 plus r to the x, okay? So the rate for this is 0.04. So I'm going to have a 1 plus 0.04. T is going to be, I'm sorry, x is going to be for time, so it's going to be for 20 years. And then how much money is he starting off with? $10,000. So let's do this. Let's first work inside the parentheses. Add this, which is a 1.04, Put the little caret in your calculator, put down 20, and then enter. That's going to give you a 2.9 or 191. Take that number, and then don't forget to multiply by the 10,000. And what do you get? $21,911.23. So in 10 years, Jim is most likely going to double his investment. So that tells you that you should go ahead and put your money in a bank and keep it there. Okay, so let's take a look at number 4. Which of the following exponential function represents a decay? Well, you know it's a decay if the inside parenthesis is smaller than 1. Well, if I take a look at it, this is bigger than 1, so this is a growth. 9/5 is still bigger than 1, so that's a growth. 5/8 is less than 1, so that is a decay. So your answer is C. All right, I'm gonna actually skip number 5 and let's go to number 6. For number 6, my goal here is to solve for x. Okay, so here you have a -3 or 3 to the negative x equals, is there any way that I can change this into a 3? Well, if I have 1/9, another way of writing that is 9 to the negative, well, is 1/3 squared. Because if we think about it, 3 times 3 is 9. Now, if I bring that up, I'm going to have 3 to the -2 power. And then from here, you can see that your base is now 3. Cancel that. Bring down your exponent, which is a negative x equals a -2. So positive x equals a positive 2. So A is your answer. Let's do the same thing over for the second part of this. Here you have 2 to the 7 minus 3x, okay? Well, 1/4 is the same thing as 1/2 times 2, which is 2 squared, which is the same thing as 2 to the -2. So then I'm going to go ahead and take the 2, cross it out. I have 7 minus 3x equals -2. So then let's go ahead and solve for this. I'm going to add the 2 on both sides, or I'm sorry, I'm actually going to minus a 7 on both sides. So minus 7, I'm going to have a -3x equals a -9, divided by -3, x equals a positive 3, which is going to be D. All right, let's take a look at number 7. For number 7, you have 2 to the 1 plus 2x. What's another way of writing 32? 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth power is 2 times 2 times 2 times 2 times 2, which is 32. So another way of writing this is I'm just going to put 2 to the fifth power. Now from here, you know you have the base of 2. That cancels. Bring down your exponent. So you have 1 plus 2x equals 5. Subtract the 1 on both sides. 2x equals 4. Divided by 2 on both sides, x equals 2. And that is your answer. X equals 2. Last question, you guys. So the last question, I want you guys to go ahead and categorize the following. What are some examples of an exponential growth and some examples of an exponential decay? What are the differences? All right, you guys, that's basically it. As always, stay safe and healthy, and I'll see you guys next time. Take care.